So today we're going to be looking at solving quadratic equations and what it really means to solve. One thing to remember is that a solution of an equation is a value that satisfies the equation. What that means, it's a value that you're going to be able to find that variable. You're going to put maybe like an x into the equation and then find out what the y equals, stuff like that. So a solution is a value that if it's substituted into the equation will make the equation true. So when the left side and the right side equal the same thing. So far in the study of math, you have probably encountered solving linear equations, which we have. When you're looking at linear equations, you only have one solution. So if we're looking at this example here, 3x minus 7 equals 8. There's only one solution for this, and we can figure out by solving it. So we have 3x minus 7 equals 8. How we solve this is we bring all the same values to one side. So we get 3x equals 7, 8 plus 7. 3x equals 15. We divide the 3 out on both sides, get x by itself, and that gives us 5. That is how we've solved solutions previously. We've isolated the variable and give ourselves what the value is. See the solution here? X equals 5. In this lesson, what we're going to be looking at is the idea that quadratic equations, which are more complicated than linear equations, can still be solved. These types of equations often have more than one solution. So you're going to have more than one value for x when you're solving it. So when you go and solve it, it requires some more complicated algebraic techniques. The value of x that satisfies a quadratic equation are called the solutions or the roots. So if we remember correctly what a root is, these are going to be our x-intercepts or our zeros. They do mean the same thing, but we've used both terms interchangeably. So an important fact about quadratic relations is they can have 0, 1, or 2 real roots. Solutions that are real numbers in this case. So remember, we can have all of these guys, 1, 0, or 2. Let's look at an example here. We have x squared minus 7x plus 16 equals 6. That is a quadratic relation. So this is what we're going to be working with here. This equation has two solutions, x equals 2 and x equals 5. We can check to see if these solutions are correct by substituting them into the left side of the equation and then solve for x. Sorry, solve for the entire equation. We're going to substitute for what x is. If the solutions are correct, then they should have the value of a 6. Remember, this is kind of like doing left side, right side, right? So if we were looking at this first one, we're going to check to see if x equals 2. So what we do first is sub in 2 for where x is. So if we're looking down here, what happens is we take 2, we put it where all the x's are, and then we solve. So 2 squared, 4, 7 times by 2, 14, and then 16 remains the same. 4 minus 14 gives us negative 10, plus 16 gives us 6. We're going to do the same thing to check if 5 works. So what we do is replace 5 where all the x's are. 5 squared, 25. 7 times by 5, negative 35, plus 16. And when we bring this all together, we again still get 6. What that means is that the values of x and 5 satisfy the equation, meaning that these are solutions to this quadratic equation. So there are other ways we can solve quadratic relations. Sometimes we can use graphing. What we're going to do is look at this particular graph and see where we can find these points. So right now it's saying -3 equals x squared minus 8x plus 12. So we want the value of x when y is equal to -3. If we look at this graph here, go and zoom in, we're looking at the 2 points in which y is -3. If we look here, we can see it happens at this spot here. So we're going to call that point one of our solutions, and it's 3, -3. And then we can see -3 for y happens again at 3 and 5. So that means our solutions here are x equals 3 and x equals 5. Our next one is asking us to find the solutions for when this equation here equals to 5. So we're going to look on our graph and see what the x values are at 5. We can see here, the first one's at 1 and 5. And then on the graph again, we can look for the other point in which the graph has y equaling 5, which is at 7 and 5. So that means our x values for this one are x equals 1 and x equals 7. Last one, we're looking at when y equals 0. We're looking for the two x values when y equals 0. Again, we're going to look down here. We can see one time that happens here at 2. We've got 2 and 0. Again at 6. So we've got 6 and 0. So that means the solution for these ones are x equals 2 and x equals 6. What we can do for each of these is to see if this works. And how you would double check your information would be to sub in the value of x into the equation and solve. We'll do one for the bottom part here. Let's try out to see if it works with x equals 2. We'll do these for all of them, but we'll try it out just for this one. So we have 0 equals, we're going to replace all of our x's with 2, so 2 squared minus 8 bracket 2 plus 12. We get 4 minus 16 plus 12. We get -12 plus 12. And we notice that 0 equals 0, so that works. There's another way we can also solve quadratic equations, and that is algebraically. And this is done by using inverse operations. So what we want to do is look at this equation here, which is 4 squared minus 11 equals 14. By applying inverse operations, so we're going to solve this by applying the inverse operation. If the solution is not a rational number, round to 2 decimal points. Rational number just means a whole number, and we're going to round to 2 decimal places. So how can we do this one? So we have 4x squared minus 11 equals 14. What we're going to start off by doing is bring all numbers over to one side that aren't connected to the x squared. So what we're going to get is 4x squared equals 14 minus 11. Okay, bring those together, sorry, plus 11, because it comes over from the other side. 4x squared equals 25. Okay, our next step is to divide both sides by 4. We want to get x squared by itself. So then we get x squared equals 25 over 4. So what we're going to do here is what we want to see is square root. We need to get this x squared to just x. And the way to get an x squared to just an x is to square root it. So we square root both sides. So what we end up getting at this point is x equals plus or minus the square root of 25 over 4. Reason I have plus or minus, because two numbers multiplying by each other, if they're negative, will still give us a positive. But two positive numbers multiplied by each other will also giving us a positive. So that means there's two possibilities that we could have as answers. So our answer can either be the negative value of the square root or the positive value of the square root. So when we get to our answer, we're going to have x1, so that's our first possibility, is 5 over 2. Now, how I got 5 over 2, the square root of 25 is 5, the square root of 4 is 2. That's how I got those two numbers. And our second x value could equal negative 5 over 2. These two values would satisfy our equation. And since it's asking us to put it in two decimal places, we can round. 5 over 2, x1 can also be written as 0.25, and our other x2 can be also written as negative 2.5. So an important fact to remember here is when k is greater or equal to 0, the square root of k refers to the positive square root of k. So if x squared equals k, then x is going to equal both the positive square root of k or the negative square root of k. So we can just write that easily as x will equal the positive or negative of the square root of k. K is just whatever we happen to be trying to square root. So that's one way to solve this algebraically. The other way we can solve algebraically is by factoring. Yes, guys, I know factoring is never, ever leaving us. Just won't go away. So what we want to do when we are solving by factoring, what we're doing is finding those two roots of the equation. So let's try with the first one here. We have x squared minus x minus 6. We want to see what the zeros, our solutions, are for this equation. So what we do is we square root it. So remember, our p is negative 6. Our sum is negative 1. We're going to go through factors a lot quicker now. When I'm showing examples, I'm just going to write them. You guys, if you still need to use a tree, that's fine. When we're doing assignments, I just want you guys to know what your factors are, okay? So in this case, our factor is going to be 3 and negative 2. So we open up our brackets, we get x plus 3 and x minus 2. Those are our two factors. Now, when we're going and finding our solution, we want to put both of those brackets equal to 0. The reason because of that is that this side here, we have it as 0. Meaning we want the brackets to equal to 0. So our solution and how we can find it is by making each bracket equal to 0. Now, if one bracket is equal to 0, when you multiply it by the other bracket, it's going to give us 0. That's just how it works. So then we get x equals negative 3 on this side. And if we made the other bracket equal to 0, so 0 equals x minus 2, x will equal positive 2. So therefore, our solutions are 3 and 0 and negative 2 and 0. Okay. Looking at B, our answer is not as clear. There's a step that we need to do before we can go and factor. And the step in this case is we're going to need to multiply this out, distribute the x in, and move the 8 over to this side. Anytime when we are trying to find our solutions, we need to make sure that the expression equals to 0. That's one of the things. We're trying to find the x-intercept, so we need to make sure that the equation is equal to 0. or what we do when we do this part here, finding the zeros, doesn't work properly at all. So for this one, we're going to start by distributing the x into the bracket. So we get x squared minus 2x, and we're going to bring this 8 over to the other side. So we bring it over here, minus 8, and we get equal to 0. So at this point, we can start looking at our product and our sum. Our product is now negative 8, and our sum is negative 2. So our factors for this guy are going to be negative 4 and 2. Negative 4 and 2 multiply out to negative 8, and negative 4 plus 2 gives us negative 2. So what we're going to do is now factor this out. We get x minus 4, x plus 2 equals 0. Again, to solve these, we're going to see what each bracket is, what the x value of the bracket is when we make that bracket equal to 0. So we get 0 equals x minus 4. Isolate x, we get 4 equals x. 0 equals x plus 2. We want to isolate x, so we shove the 2 to the other side, and we get x equals negative 2. So therefore, our solutions for these guys are 2, x equaling negative 2, and x equals 4. Let's move over to the next one. So this case here, what we have is 5 on this side, and we want to make sure that this side equals 0. So what we need to do first is move that 5 over to the other side of the equation. So when we write this out, we get 3x squared plus 16x. We move the 5 over to the other side, it's negative 7 plus negative 5 gives us negative 12. One thing that we notice, this is a complex trinomial because we tend not factor out 3 from 16. So what we're going to need to do is do some decomp, or Australian, whichever you prefer. Our product this time is negative 36. Our sum is 16. Our factors for that are 18 and 2. Sorry, positive 18 and negative 2. So we get 3x squared plus 18x minus 2x minus 12. This is still equaling to 0. Our factors, we're going to pull out some information from this one. So we get 3x bracket x plus 6. Look at these two, pull out the common factor, which is negative 2, x plus 6. All of this is still equaling to 0. And we get 3x minus 2 and x plus 6 equals 0. And just as we've been doing every single time before, we are going to make each of these brackets equal to 0 to solve for what our zeros are. Just going to switch colors to make it a little bit more obvious this time. So we get 0 equals 3x minus 2. We're going to take the 2, bring it to the other side. So we get 2 equals 3x. Now we're going to divide both sides by 3. And 2 over 3 equals x. That's our first one. Next one we want to find is our other bracket. We have 0 equals x plus 6. X equals negative 6. Okay. That's our first one. Those are our two solutions. So let's go over and look at this next one. What we want to do now, again, we want to make sure that one side's equal to 0. So we need to bring that 7x and bring it over to the other side. So what we get is x squared minus 7x plus 12 equals 0. Okay. So this looks like a normal trinomial. We have our product equaling 12 and our sum equaling negative 7. what are some factors that we can use here to get -7? Well, it'll be -3, -4. We wrap our brackets, we get x minus 3, x minus 4. Okay, that's our little part here. Make them equal to 0 on both sides. And we get 3 equals x and 4 equals x. This principle holds true for every single one of these that we're going to do. I'm going to stop the video for this one now. I will have online the PDF that has the last 4 answers done. They follow the exact same principle as every single one before. For time's sake, I'm just going to post the answers for these ones. That way you're not watching a super long video. Right? So hopefully you guys are working on these, find them pretty easy. Your homework is to complete the assigned work as usual. Answers will also be posted online. Have a good day, guys.